get a little better. Okay, so we're back in vet school. So today we started off with Physiology and Histology 2, and here's what we talked about in that class. So, first of all, today was the first day, so it was a lot of just introduction and stuff, syllabus, that sort of thing. Introduction and syllabus. Okay, so here's what I learned. So not all kidneys are shaped the same. A dog kidney looks like ours. A pig kidney kind of looks like ours. Horse kidneys are kind of heart-shaped. Cow kidneys or bovine kidneys are lobular. They have lobes. And then dolphin kidneys are very different. So they all have the same overall purpose, though. Okay, so cats are the ones who most commonly have kidney disease. If something's going to have kidney disease, it's commonly going to be a cat instead of anything else, basically. The functional unit of a kidney is the nephron. Kidneys control blood pressure and volume by controlling water content of the blood. So if you drink too much water, your urine is going to be more clear because you're going to excrete excess water. Whereas if you are dehydrated, you are going to have more concentrated urine because your body's trying to conserve that water and save it for more important bodily functions. Kidneys also control blood pH by either excreting less or more bicarbonate into the blood. But they're very, very complex organs, and I would show you these pictures, but they are not mine to show. These are copyrighted materials. Hey, Elith the Gamer, how are you doing? Good to see you all today, or talk to you all. I guess I'm not really seeing anybody, but my phone's kind of slipping. An efferent anything is the exit, and an afferent anything is the entrance. So an afferent arteriole is an arteriole that's going into whatever structure, and an efferent arteriole is an arteriole that is exiting that same structure. So again, very good pictures here. My man's kidneys are acting up, but so is he. So I'm not sure what to tell you, little Chrissy. Is that a question, or if not, then I'm not trying to be mean or anything. I'm sorry to hear. Sounds like a hassle. Kidneys basically just regulate water. Okay, you drink too much, they're going to excrete excess. You don't drink enough, your body's going to conserve what it's got. We didn't have that many notes for today because it was the first day of school. Intake versus output. If you intake, okay, let's say we intake 2,500 milliliters of water in a day. Your excretion or your output in a day might also be 2,500 milliliters. Okay? But let's analyze the components of those. So in the intake, about 60% of your intake is going to come from beverages: water, soda, orange juice. Not that soda and orange juice are good, in my opinion. Oh, yeah, yeah, yeah. I get you. Yeah, I know what you mean. Uh, I know someone also who used to drink a lot, and, you know, lots of bad stuff happened. But yeah, alcohol's not really, in my opinion, probably not a good thing to put in our bodies. But some people enjoy the way it makes them feel. So I don't understand it, but you know, everyone does something that other people aren't happy with. Sin. I mean, I used to struggle with sins that other people didn't struggle with and probably thought were weird. And other people struggle with sins that I think are weird. That's just how we work. That's just how humans work. But all we can do is try to be better. Sorry, not trying to make this all uh, philosophical. The kidneys and the livers are not a fan. I don't drink personally because I can't with my anxiety meds. Yeah, drinking's just probably not a good idea in general. Not good for the kidneys, not good for the liver. That's true. Uh, Fatty liver disease is a complication as a result of alcohol intake, because alcohol is a waste that your body tries to get rid of, and so of course it goes to the liver, which is the waste processor, basically the filter, or one of the filters. The kidney is basically the liquid filter, and the liver is basically well, I wouldn't say solid filter because things like alcohol go through it, but it filters as well. And you can get fatty liver, or alcoholic fatty liver, and non-alcoholic fatty liver for the same reason. You've got alcohol going through the liver, or you've got fructose going through the liver. Yeah, alcohol's not good for your liver or kidneys. But I'm sorry to hear that. Hope everything gets better, or if it's not so much bad, I hope he feels better or gets healthier. And yeah. Anyway, metabolism is about 10% of our water intake. So our body generates about 10% of the water that it needs. According to this graphic, it might not even be our bodies. It might be a dog's body or a cat's body. Foods account for about 30% of our water intake. Beverages, 60%. Now, water excretion, feces is about 4% of our water excretion. There is some water in our poop. Sweat, about 8%. And then there's something called insensible losses, which are losses via the skin and the lungs. So if you get a burn on your skin, that's going to increase water loss. It's when your skin has that barrier removed, it gets more challenging for your skin to hold water. Lungs, just simply breathing loses water, especially if you breathe out of your mouth predominantly. So that's why people might say to breathe in through your nose, out through your mouth. That's because your nose has all sorts of filtering and conditioning to filter and condition that air that comes in. Finally, urine accounts for about 60% of the average water output. So predominantly you lose water through the urine, and predominantly you gain water through drinking water or any other beverage that contains water, but mainly water, because things like alcohol, coffee, these are diuretics. They make you pee more, and so that can cause more water loss. So that was basically all for renal physiology today, or the class itself is called Physiology and Histology 2. Veterinary Physiology and Histology 2. So then we had general pathology. Basically, the goal in this first lecture was to know terminology, I guess, know the differences between cytology and histology, and then know the differences between morphologic diagnoses and etiologic diagnoses. So, yeah, blah, 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 blah. Blah, blah, blah. Well, I probably need to write this down. That'd be a good idea. Yeah, cumulative exams. Okay. So pathology comes from the root words pathos, which means experience or suffering, and logia, which means the study of. Those are Greek, I believe. So the study of disease, basically. Cancer, inflammation, inherited, all sorts. So pathology is the study of disease. Pathogenesis is the formation of disease. Pathophysiology is the study of altered physiologic function due to disease. And there can be simple pathogenesis or complex pathogenesis. For example, a simple pathogenesis could be a dog ran out into the street, got hit by a car, broke its leg. I mean, obviously the car broke the dog's leg. It's not really a puzzle, and that's why it's called simple pathogenesis. Complex pathogenesis, you could have pathogens entering through some luminal barrier. You have, your immune cells trying to attack those pathogens. Pathogens get into the blood. They affect the Kupffer cells of the liver, which are a type of macrophage. And then those immune cells send a signal to the brain to start a fever, basically. The fever is a result of the pathogenesis, but it's a very complex pathogenesis. It's not just as simple as a dog got hit by a car, broke its leg. A lesion is any abnormality resulting in structural and or functional change. A gross lesion is a lesion that's visible with the naked eye. That doesn't necessarily mean it's nasty. It's not that kind of gross, but it could be. I mean, a broken leg isn't exactly pleasant to look at. A microscopic lesion has to be viewed microscopically, and it could be a matter of histologic versus. So histology versus cytology. Whenever people, and here's another thing, whenever people say pathology in the context of saying, oh, this dog has pathology associated with this, that's incorrect terminology, because pathology means the study of disease. So this dog has the study of disease. What? Nah, it doesn't make sense. It'd be more concise and correct to say this dog has a lesion associated with, or a pathologic lesion, right? Antemortem means before death, so a living animal. Post-mortem is dead, so post means after, mortem means death, ante means before. Okay, gross versus histologic lesions. Gross, again, means visible to the naked eye, and histologic means it's microscopic. So you could see a liver that's, livers are basically supposed to be red. If you see a liver that's anything more pale than red, it's like textbook fatty liver. You see a yellow liver, that's basically fatty liver. What other disease would cause a yellow liver? I can't think of one. Correct me if I'm wrong. But now then there's other things that are histologic that can also... Okay, so first of all, let me say, fatty liver disease or hepatic lipidosis is a pathognomonic disease. Like, you see it and you're like, okay, that's fatty liver. You can just tell. There's no debate. You're 99.999% certain that it's going to be that disease. And again, fatty liver is an example. There's also Johne's disease in cattle. Comparing a normal cow ileum to an abnormal cow ileum, it's very textbook. All right. There's also, so a diagnosis is a conclusion or conclusions regarding the nature, cause, and development of disease. So you have to examine antemortem animals, because if they're dead, it's not a diagnosis, it's a necropsy, right? Or something like that. A clinico-pathologic diagnosis is based on the clinical diagnosis and other findings. And then a morphologic diagnosis is used by pathologists. It's basically the bottom line. It's a summary diagnosis following gross and or microscopic evaluation of tissues. It usually a morphologic diagnosis contains the degree of how severe something is, the distribution, the duration. So the degree, the distribution, the duration, an adjective, and a tissue process. So how severe it is, where it is, how long it's been going on, typically an inflammatory term afterward, like an adjective. That's where that adjective comes in. And then the actual condition or process. 3D ATP, degree, distribution, duration, adjective, and then tissue process. All right, an etiologic diagnosis is a diagnosis that provides the cause of the disease. An etiology is the cause or causes or manner of causation of the disease. For example, Streptococcus bacteria is an etiology or etiologic agent. An etiologic diagnosis would be like streptococcal meningitis. That strep caused that meningitis. A morphologic diagnosis, in comparison to an etiologic diagnosis, is the process, whereas etiologic diagnosis is the cause. So heartworms. The morphologic diagnosis of heartworms would be moderate, chronic, regionally extensive eosinophilic endocarditis with intraluminal nematodes. So that's a mouthful, right? But that's the process. Now the cause is dirophiliariasis. Dirophiliariasis. That's literally just means there's heartworms in that heart. That's the cause of this pathology, or of this lesion. Sorry. The process is moderate, chronic, regionally extensive eosinophilic endocarditis with intraluminal nematodes. Okay. And now, if we have an example of hardware disease, so a cow gets a nail in its pericardium, in between its heart and its pericardium. There's going to be extreme inflammation, extreme attempts by the immune system to get that nail out. They're not going to be able to, of course, because it's an inorganic object. But the morphologic diagnosis is severe subacute diffuse fibrinosuppurative pericarditis with a nail in the heart, or around the heart, basically, or a piece of wire, or whatever's stuck in there, The etiologic diagnosis is traumatic reticulopericarditis, otherwise known as hardware disease. You literally get some hardware in wherever is being affected with the lesion, in this case, the heart. So, veterinarians use a list of differentials: degenerative, anomalous, metabolic, neoplastic or nutritional, inflammatory or infectious. Whenever you've got inflammatory, you've got infectious, non-infectious. There's iatrogenic, idiopathic, and then there's traumatic or toxic, and then vascular. These are all things that can cause disease. There's two types of pathologists: clinical pathologists and anatomic pathologists. Clinical pathologists study bodily fluids and cells. They are basically looking at the individual trees. Anatomic pathologists study organs and tissues. They're looking at the whole forest, basically. So clinical pathologists might look at blood, urine, effusions, cytology. And again, cytology is the study of cells, whereas anatomic pathologists are going to study organs and tissues. So they are going to do autopsy, necropsy, and then they're going to look at histology, which is the study of tissues. They're going to look at the architecture of the cells, etc. Gross examination, again, gross meaning visible with the naked eye, is going to be achieved via necropsy or autopsy. You collect tissue, and it can be fixed with formalin, or it can just be a fresh tissue. Whereas microscopic examination is usually going to be via histopathology. These are still tissues collected during necropsy, but you're looking at them under a microscope. Or it can be, this is where it can be helpful, it can be biopsy tissues. These are collected during surgery of a living patient. So you don't have to, the patient doesn't have to be dead to look at these tissues. All right, and that's basically it. Honestly, I don't see much else here. Yeah. All right. Well, thank you all for watching, and I suppose I'll see y'all on the next one. Thanks for watching.